Okay.
Yeah.
I actually think we're missing our minutes taker.
Who is our minutes taker?
Eric.
Eric, come here.
Yeah.
Yeah. Has anyone seen him? Tommy, have you seen Eric today?
Yes.
Eric, come here.
Yes.
Eric, come here.
Yes.
Yes. Okay. He woke up. That's good to know.
Yes.
Okay.
There's a question about that?
Well, he's supposed to be taking minutes for us, and he's not in the room yet. So.
Okay. I need Eric for an idea.
Okay. Can you put him in the Etherpad? Excellent. Thanks.
Thanks.
Really not?
Okay. Welcome to the last session of this IETF. Yeah. Okay. So we used to have a minutes taker who disappeared. We need a Jabber scribe still. Sorry, my fault. I should have organized it beforehand. So any volunteers? Oh, come on. Please. We need to automate this. Okay, we still need a Jabber scribe. Oh,
Yep. Aaron, excellent.
thank you. So, God, why it's happening to me all the time? Okay, this is not well. This time it's right, not well, because Brian did that. It's not me. Yeah, we found everyone. So agenda.
I'm sorry, I'm going to have to bail on being JavaScribe because my client is not working. So
okay,
someone else
Aaron,
could take over.
Okay, Aaron.
Yeah, Aaron, yeah. Cool. Yeah, this is actually, the right timing on the agenda. Any agenda bashing? Last minute suggestions? No? Good. We have 2 active documents which we are going to discuss, and we have 1 document, individual draft, which we're also going to discuss today, and we have 2 guest talks, and I think we're good to go, but when you go to the microphone, please state your name, affiliation, and other information you think might be interesting for a minutes taker. And so the first presenter is Brian. Let me get your slides. No. Yes.
Do I have a thing?
I don't know if it works.
And we have Eric now, so we have like 3 minutes takers.
I fought valiantly, but I got away.
Okay. Excellent. So hi, I'm Brian Trammell. I am, for purposes of this discussion, not the co-chair of PANRG, just some guy off the street with a research group draft. This is open questions in path-aware networking, which basically the feedback we got at the last meeting was to change the title to current open questions in path-aware network. This was you, Aaron. I don't know what you look confused about this. The idea was, if we're going to snapshot this, then we should probably make it clear that this is something that is, as of the point in time as in publication. So we changed some of the front matter. We changed the title. We kept it from expiring, and those were the 3 things that happened when we submitted that draft. Just for a review, there are some open questions. I am not going to sit up here and read this. I think that everybody who is interested in this draft has already read these multiple times. It turns out when I wanted to make my slides for this presentation, all I had to do was copy my slides from Montreal. And when I say Montreal, I mean 102, not 105. So this document has now been stable for about 16, 17 months. I did change sort of the annotations over here. So how are path properties defined and represented? Since the last time we talked about this draft, there is now a individual draft that talks about that. So more the defined than represented, but there's a semantic layer and then a presentation layer.
So Aaron Falk, so given the fact that the questions haven't changed in such a long time, I suggest that we remove current from the title and make it perpetual questions and path-aware network.
Stable questions.
Next slide. I am like draft revisions are free. Like it's actually done by Circle CI, so it's like pushing a Git tag, so I can do it. Is that a serious question, or is it just Friday and you're being snarky? I can't tell.
Sorry, it was a snarky comment on the lack of contributions to the answers to the questions.
Right. Oh, okay. That's a better joke than a joke I thought you were making. Okay. Thank you.
Spencer Dawkins. Or it could have been a non-snarky comment on the idea that research questions don't change very often.
Right.
So
it was
there's
just
that.
So I was just in another working group where the word recent was spin bitted, and like it's like, oh, we shouldn't talk about recent because this is going to be perpetual. It's like, so I think that we can leave current in there, and the current means perpetual. So that way I don't have to push another Git tag. There was one minor change to this list of questions from some discussion that we had sometime between 2 Montreals ago and now. About the transition, right? Like, so we're talking about in this 8th question. So this is the thing that's in italic here is the new text. This incentive alignment is not just about, the greenfield creation of these kind of networks. It's the transition, right? Like, so this is taking from a careful reading of planning for a protocol transition and adoption. We're planning for adoption and subsequent transition. So the failure draft, the failure RFC. Go ahead, Eric.
Eric, not Mark. So we had this reliable and available wireless bot earlier this week. And as part of this discussion leading up to that, we asked, is PANRG doing something? And I went and looked in this draft to find out about whether you have discussed this sort of time aspect of the properties. So particularly with wireless, we have some path properties that might vary extremely quickly over some particular wireless link as opposed to the end-to-end properties of the whole path, right? And I don't see any mention of that in the draft. I was just curious whether you guys have talked about that stuff.
A little bit, but not in the draft. So,
because part of it is, I guess, the purpose of if you're trying to find out about a whole path. Right?
Yep. No, I get the question.
Very,
yes,
very
that's
then.
actually important to capture here. Yeah, actually, can you frame your you've read this draft, I presume, at one of its revisions, all of which are basically the same. Let's sync up offline about getting text from that comment into question form, because this is path-aware networking Jeopardy, so everything has to be in the form of a question.
Teresa Enghard. So I think the previous question relates to path properties, which is also related to my draft. So
right. So you actually do. We did actually start the discussion about the temporal characteristics of these properties. I think the question should capture that, because they don't, right? Like, so when you started trying to answer the question, this other question came up very quickly and you kept answering it, but the questions draft should point out that this is a thing. So I see Eric typing furiously over there, and I hope that he's sending a PR on the draft. Mm-hmm. But yeah, I think yes, we're going to talk about that a little bit more in your thing, but it does need to be in this draft, which means these meta questions on the question draft are overtaken by events. We discussed this a bit. It hasn't changed much. We're going to change that. It will. I would propose as editor to publish on the IETF stream. I would actually say propose as editor to publish on the IETF stream after some discussion on the mailing list after a 04 rev that has Eric's text in it.
Just to add to the thing that you said, I'm willing to help add something to the first question, which my document is trying to answer.
Okay,
and also
cool.
I've read a number of versions of your draft, and I'm willing to go over it one more time.
Okay, cool. Thanks.
Just to double check this, I'm super happy to give you an RFC number for that, but given the word current is in there and it actually has some meaning, does it actually make sense to publish it as an RFC? Or is it just like something we need to know about in this group and then work on the questions?
So I thought about this back at we've discussed this in the last 3 meetings, and at each meeting we land on a different answer. And I think that like right now we're in the phase that it's published. So if we manage to drag this out to Vancouver, it'll be don't publish. My thinking on this has changed over time, and where I am right now is publishing this as an RFC has the advantage of giving people who are working on technologies and techniques and stuff in this space who are not in this room something that they can wave around and say this is important, and I think that's a service to the community.
That's a good answer, and I want to state my name because I forgot. Mia Kulevind.
Aaron Falk, plus one to what you just said, also referring to my last comment, given the fact that the answers are coming rather slowly, I suspect that these questions will be around for a while. And in fact, this would be great input for, say, an activity that's looking at a vision of the network for 2030 to have some real research questions to chew on that would be
okay, so that's two for we should probably publish, but let's not have that discussion right now because there's going to be text edits coming in to talk about the temporal aspects of things. So like on the current versus not, I mean, like we can multicast the title a bit if we want to, but I think we should probably do that on the list. Yeah, we already spin-bitted the agenda, so we have to multicast the title. Other questions? Thank you very much. We will follow up on the list, and I hope to get this done with my editor hat on before Vancouver so that we can just say, hey, it's gone up to the IRSG before Vancouver, and then it'll be their problem. Thanks.
Okay.
Hi, I'm Teresa, and I'm here for an update of the path properties draft, which I prepared together with Cyril before this meeting. So we got a bunch of feedback at the last Montreal, which was 105, and we got an extensive review on the list by Med, for which we're really grateful. So I just, as a first thing, I just wanted to remind people of the scope of this particular draft. So there was a question on like, is there some architectural reference of this draft? And we think it would be really interesting to have something like more fleshed out, more concrete, but the architectural reference that we see and that we now link to in the, or that we reference now in the abstract or in the introduction is basically what the questions draft says what a path-aware network is. So the path-aware network exposes information about the forwarding paths and the services associated with these paths to hosts or to other entities. And in the path properties draft, we want to talk about this information, like how can we define this kind of information that either the host or the other entities would want to know, and how do we express them? And to answer this question, we need a common terminology, because if people from different areas say path, they sometimes mean like very different things. So we had a look at a bunch of different definitions, and now we're trying to find a common language for this research group to talk about paths. So we still have nodes, and nodes process packets, and those nodes could be a physical machine, they could be a virtual machine. But now we expanded this definition a little bit to include, for example, a software component, for example, a service function or implementation of a service function, but we are probably going to talk about it a little more abstract. So you could have a path that consists of multiple nodes that you sort of chain to each other, because each of those nodes processes packets in some way. And otherwise, a node could also be a little more abstract, like a collection of multiple physical devices, maybe even an entire autonomous system. For example, if you want to talk about a path and you do not care about like each individual device that is on the path, or maybe you just don't know, or maybe it changes. And so a node can also be this kind of more abstract thing or more concrete thing. And we still have one special case of a node. Because we talk about hosts so much, we decided that we would keep the definition of hosts, but our other definitions do not depend on it, but we talk about hosts a lot in like other parts of the draft. So that definition is now aligned with RFC 1122. And then there's links which basically allow one node to send a packet to another node or even to multiple other nodes. Our links are unidirectional. So if you want to model bidirectional communication, just use two links between, for example, the same nodes, which basically allow to send packets in opposite directions. And now if you can sort of align those, or if you have multiple of those nodes, one after the other, each of nodes and links, one after the other, they are path elements. If you can transmit a packet over these path elements, then this is enough for them to form a path. So you can have a path that includes node, link, and then there can be 3 nodes. For example, for the service function chaining use case, we need this. So it depends on kind of your granularity. And then the path is defined as the sequence of path elements from one node to another node. Doesn't have to be a host, can of course be like both hosts, but there can also be overlay nodes, for example, and we didn't want to have like a clear distinction between what is a host, what is a router, what is an overlay node, because then we might unnecessarily constrain our definitions. So now we just have like one node, another node, and there can be a packet sent from one node to the other node across those path elements. And then subpath is just a subsequence of this path, doesn't have to start and end with a node anymore. So we can just talk about maybe 3 nodes or 3 links or something like that. And then the packets, so the flow is packets that can, for example, be sent from one node to another over a given path, but we didn't want to constrain our definition to imply that all the path elements have to stay the same, because maybe you send multiple packets and somewhere on your path, maybe it just has like a load balancer and then packets take one way, the other way, and so on. Maybe you want to still collectively refer to those packets because they are between the same nodes, right? And so we basically have a flow that is just a collection of packets, and we want to talk about these packets sort of as a collection and apply a path property to them. And then the property definition essentially stayed the same, but like the components that it refers to changed. So we think now path property should work as a definition. And we give a number of examples for path properties. So note that we removed the classification into domain properties, backbone properties, and what was the other, dynamic properties. But now we basically have a list of examples of path properties, which might be interesting to know for the host, such as what access technology do we have? Is this a Wi-Fi link? Is this a cellular link? Is this like Ethernet? And does it cost money to transmit packets across a network, across a link? Then the administrative domain is a new property, which we basically morphed this aspect that maybe you care, like who owns a path element on your path or sequence of path elements, and that is the administrative domain property, which can, for example, just be it belongs to an autonomous system, it belongs to a certain service provider's network, or it might also be like more fine-grained. For example, if you have multiple routing areas within your AS, maybe you want to refer to one of them. So this is all possible with this administrative domain property. Then you might care about different paths in terms of what features or what protocol features do they support. And then there's these transmission related, so transmitting a packet or a flow properties, for example, expressing the capacity or usage of links or the delays. So those definitions we aligned with basically with existing RFCs, such as written by the IPPM working group, because we do not intend to like redefine properties that are already well defined somewhere else, right? So yeah, we have this list of examples of path properties, and of course, this is not an exhaustive list, but just a few examples. So we wanted to motivate our examples, and that is why we have the use cases section in there. Actually, this section is not new. It was part of the introduction before, but now we explicitly made it its own section. And those are 3 use cases that we came up with, also with the help of our reviewer. And yeah, basically those are examples why a host or another entity might want to know about the path properties that we have in our draft. And with this, I'm going back to like the bigger picture, sort of the scope of this draft and the context. So we have asked for adoption on the list already. There was not a lot of feedback at the time, so now I just would like to ask again. So does the research group think that these terms and like this draft serves or may serve as a basis for us as a research group to come up with a common terminology so we can talk about path properties in the context of this research group and maybe later on for people reading this draft?
Hello, Tommy Polly, Apple. So I think we should adopt this. It's a good starting point. And thank you for the work on the most recent update. I think that does help clarify. I appreciate all the work to incorporate this. It was not a trivial change. I think the terms do work. I think they're more narrowly scoped than something we saw before, so that was good. One thing that just came to mind kind of as an aside, so we have the notion of node in here, which I think is nice in general, and it's, I think, general for a purpose. Should we have some specification of a certain type of node with regards to path awareness? Because we're talking about path selection in here, and so there are certain nodes that I may traverse that I can't do anything about, but there are other nodes that essentially allow me to make choices, right? Like things that are, I think as you mentioned, transport converters, or I have, you know, things that can help me do MPTCP, or like things that can act as proxies, or nodes that enable path selection, and potentially even when we talk about measurement, nodes that participate with the client in path measurement. So they are so essentially there are transparent nodes, and there are nodes that you can use for measurement or selection that are enabling some future techniques. And so maybe just having a definition, because of course we don't necessarily know all the mechanisms that we'll want going forward, but defining these stances a node can take would be useful.
Yeah, I was thinking that maybe we could express something like that as another property, like, oh, this node has the feature that I can do stuff on it, right? This kind of thing. Maybe that works.
Hello, this is Sabine from Nokia. So just to make sure I didn't miss anything, all those information that you list on path properties, so you assume they will be generated automatically at the side of the endpoint, of a starting endpoint? Then I have a bunch of questions, actually.
So I do not assume they will automatically be generated or available. I'm coming up with with definitions of how to talk about those properties if there are like devices that can come up with them, right? Or if there are devices that sort of can process them. But how we would exactly measure them, how we would communicate those properties from, for example, a path element to the endpoint, that is another answer to another research question. That might be another research group draft or something else. So this is just about the terminology. So I do not assume this will automatically happen just by providing a terminology.
Okay. So the next question is that it seems that you may want to design a representation format and for those paths and their properties. I have actually this looks very similar to what is done in Alto. Alto defines a feature, a service that is called path vector, and that may be useful to your work because between two endpoints, you make a you make a breakdown on what happens between two endpoints, and that can be. This is kind of this would support what you would like to have as information. Maybe a couple of interesting features that you mentioned, like the list of available transport protocol end-to-end, that may be useful. So may I invite you to write the draft on path vector? And I think there would be room for some common work about it. Maybe you already read it.
So I've read a number of different drafts that relate to different definitions of a path. Yours sounds more like the transport perspective. So we have on our GitHub repo where this draft is being developed, we have a wiki where we also list some working groups and some RFCs that are related. We have Alto in there, I believe, but I'm gonna go back and check the specific path vector that you mentioned, and then we can talk about more.
Okay, thanks.
Thank you for your comments.
Hi, Brian Trammell speaking as an individual. Actually, I wanted to come up here and say, yes, I think this is a good start. I think we should continue this discussion in the research group. This is what we're here for. I have a couple of things that I would change, but I don't want to make those from here because I don't want to. Let's see, we've already used SpinBit and multicast. I don't want to put it in the DNS. The Tommy's thing, I think he just did that and then ran out, didn't he? So Tommy's idea is intriguing but terrifying. I would not want to see us try to go down the path of node properties or node classification in the path properties document. I think there is some room for talking about the types or classes of functions that a node might like. So I like the idea of saying this is a transparent, this is an intransparent, this is a layer X, this is an endpoint, right? So that beyond that, I don't think we want to, because between there, you do that, and then there's a whole bunch of unclarity, and at the end of it, you get to mud, right? Which is trying to solve a completely different problem.
But we do already have service functions in there, which can also annotate that, oh, this is a firewall or something like that. So we could.
So I would want to be very careful about trying to do an ontology of every service function on a network.
Yeah, exactly. That's not what I'm trying to do.
Right. Yeah.
And also, of course, we can that is the intention to bring it into the research group, and then we can work on it more as a research group.
Right. But so as an individual contributor, I just say that I'll be sort of aggressively pushing toward trying to generalize the things in this document as opposed to make them specific to a particular thing. I also think that so there's definite overlap here with Alto with respect to the path vector. I think there's a very clear line between the responsibilities of Alto in terms of building representations of these things, and the PANRG should work on abstract vocabulary. If we get to the point where we're actually saying this is a wire encoding of one of these, that's IETF work.
But we already say that the path property is the sequence of path elements, and then some tuple of flows or something we already have something along those lines, and I wouldn't want to be more specific.
That's an information model, not a data model. Information models are fine. Data models are not. Well, I don't want to get into Yang. So that having been said, yes, I support adoption of this. Let's keep working on it. Let's work on it here.
Joachim Fabini, a statement on the same topics on Tommy's comment. I find it very interesting to have this property of a layer X transparency. You can formulate it mathematically. You can aggregate it on path aggregations on subpaths to formulate that you have a transparency on a specific layer, which means that you have a kind of end-to-end connectivity for this specific layer.
So
Or
you mean, just to make sure I understand what you're saying, you mean, for example, there's like a layer 3 device, and then all the layer 2 devices between them are sort of abstracted from, and they sort of don't know about the layer 3 or vice versa, this kind of thing.
All these nodes in between are characterized as layer 2 transparent, which means, and layer 3 transparent, which means that just the end devices communicate directly at a specific layer. Also mathematically, it could be interesting. And just one additional.
Sorry, could you like provide a reference or something to that to the list? Because I would like to see like how do you express that mathematically? Because we did have something like that in, I think, previous versions of our definitions, and then we were like, nah, it's kind of hard to express. So I would just like to take a look at like how you mathematically express those. So that would be cool.
Okay, I can think about it. Is good. Second, about security. Is there any metric on security, any property on security, encryption at a specific layer? Because this was also a topic that has been addressed.
So what I could imagine is to have to talk about trust in some way, but this is really complicated. I'm not sure, like I don't think you can capture how much you trust a certain path element as a property. Yeah, but otherwise, what do you want encrypted? Your traffic?
Security.
Like, is it like, oh, traffic is encrypted between this and that other? But still, you have to qualify it. It's not like encryption is not the same as encryption, right?
Yes, I meant at a specific layer, a protection that is either through signatures or through encryption done from end node to end node, in a sense to say, corresponding to the threat model that we're defining now.
I am not sure I'm defining a threat model
No,
in
you're not
here, but we're
defining, others are
gonna
defining threat models.
yeah. Yeah, I
threat
think
models, and it might be interesting to characterize a path with respect whether it is liable to a threat or not. But
I think
I'll come back
the
to
trust
that
question is really interesting, and we should revisit it once we talk more about like how do we get a trustworthy and like how can we characterize
thank
it?
you.
Sure. Thanks.
Philip Teasdale, speaking as an individual. First, really thank you for doing this work, because we've seen it maturing a lot, and I think it's definitely in a state where we should adopt it and work together on it as a working group, or as a research group, sorry. Tommy's comment also made me think and made me stand up for more details. I think it's very good starting with a generic description of a path, like just being a set of nodes or a sequence of nodes. I don't think that things like nodes that could do stuff or couldn't do stuff are something useful, because I would rather prefer network functions that could be on the path as two different paths. So one with the node, one without the node. Besides that, the idea of whether the node is transparent or isn't transparent, so whether it's actually breaking the end-to-end principle or whether it isn't breaking the end-to-end principle, is an important property. I'm not sure whether we need this in the basic definition, or that's one of the first properties of a node one wants to define.
Right. So yeah, as I was saying, we don't define an exhaustive list, but yeah, this is definitely an interesting one, and let's think about it.
Another interesting one I see is whether this does not break the end-to-end principle, but passes information along. So like a measurement node that's giving you some information that's passed along with the packet.
Then we would have to define what breaking the end-to-end principle means, and I don't think I want to define it in this draft.
That's a good question, whether we want this. Thank you.
I'd like to cut the line.
Mia Kulevin, thank you for the work. I'm actually a +1 on at least exploring the idea of adding transparency or definition of transparency here, because that could be very useful, but we could also fail about that. But I also don't think we have to decide before adoption. Can work on that. But the actual reason I came here was that about the use cases you've added. So I think it's a very good approach to look at the use cases and figure out, like, based on the use cases, what we need and what we want. But right now I find the use cases rather a little bit confusing. Because, for example, you talk about performance monitoring, and like performance monitoring for me is something very like, I want to know, does my network work right now, right? And I don't think that's what you're looking at. That's actually kind of what you're explaining very lengthy in the next section, talking about examples that is not about this like current state, but more about general properties, right? And that's also everything that's related to measurements. Always the question is, what's your measurement time frame, right? Is this something you've been measuring over the last second, or do you take the average over the last week, right? This is very different. And like my understanding was that like this whole group actually was more scoped on something that is not over the last second, but something like more long term. I don't know, maybe a discussion to have. But like right now I'm a little bit confused here.
Okay, yeah, so definitely open to contributions to this use cases section, because yes, I agree it needs more work. Performance monitoring, I think as the definitions work right now, we can have both. We can have like the very short term, because like the property would be defined on maybe a single packet and one-way delay of a single packet, and then you can aggregate, and then you can aggregate over the last 10 seconds, last hour, week. That's all possible, right?
That dives very much into like the measurement method about how to access this metrics rather than what the metrics actually means, right?
But I mean, isn't that like two separate things? How do you define the metric and how do you like communicate it, access it? How do you measure it? We're not attempting to answer that question, right?
But what you say basically, it's I leave the metric undefined and it depends on the measurement you use. I would rather define the metric and then look for the right measurement for it.
Okay, I'm gonna come back to you on that. That's okay.
We have the same discussion in Ultra actually. And traffic configuration is a little bit the same, because right now what you protocol selection would be the right title for me, because that's the thing you really want. But like traffic configuration sounds like you're diving into doing congestion control here.
Right. So this can be protocol features, but it can also be like application level modifications to what you're sending as a host. So I wanted to keep it more general, but traffic configuration was just a term I came up with like at one point, and of course we can change it or maybe split those use cases and like make them more
So the use
concrete.
case talks very much about protocol selection. I think that's a very good use case. Let's start with the simple ones first we know about, and then maybe extend later.
Hello, Max Franke. Just a really quick and easy clarifying question. I think it's fairly obvious, but you state that links are unidirectional explicitly and paths are also unidirectional, right? Okay.
Andrew McGregor, Fastly. I could have a lot to say about this, but I'll just restrict myself a bit. Firstly, representing different modes of a path as separate paths is a really bad idea, because what you want to do is represent where the shared resources are. And if you say, okay, at this point you could route it through that tunnel or not, then what about the forwarding resources on the on-path nodes that are in the unforwarded version of the path? How do you represent that you're sharing buffers between the two versions, right? So that's no, don't do that.
Right. So you're saying that those are like two different paths.
They are not two different paths. They're one path that can operate in two different modes.
Oh, right. Right.
Yeah. And it's the end of the week, and the other things I was going to say have fallen out of my head, so I'll sit down. Thank you.
We have a mailing list. So like in 3 weeks when your brain's back.
Yeah, and the list been very quiet, right? We did call for adoption on the mailing list, but unfortunately we have not received many comments. So I think we shall can we just harm for adoption? If you think this should be adopted, please harm.
Okay, sorry I interrupted the hum. I'd actually like to see a show of hands of who's read the draft. Yeah. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. Okay. So order a dozen. That's reasonable. Yeah. So now I'm going to step back. So
Okay, just in case, if you think the draft should not be adopted, please hum.
Wait, that was a not adopted?
Not.
That was a no. Okay, let's rerun the hum, because I.
Let's do it. I'm confused.
A little quickly, Jess.
Yeah.
Say it again.
Okay, so let's do it again. If you think this draft should be adopted, please hum. Okay. If you are against adoption, please hum.
So from up here, the acoustics are not the most terrible in this venue, but they're not great. I heard sort of like, lukewarm to warm support for adoption and crickets on non-adoption, which seems like adoption to me.
It wasn't quite crickets for adoption. Someone did hum, but it was very thin.
Huh? For non-adoption.
Yeah, there was like one.
There was one cricket. Okay. Okay.
Yeah, cool. Thank you, Teresa. Spencer, you are next.
So who's read this draft? Thank you. The picture was mostly the question was mostly just give me time to take the picture. So I'm Spencer Dawkins. I'm talking about the what not to do draft, which was something I can give just this much background for people who haven't read it. From the beginning of the research group work, one of the things we said was that we've had a lot of path-aware networking mechanisms that didn't get deployed, and they keep not getting deployed for many of the same reasons. So we should write those down. So this is what that document was intended to be. To put my last slides first, but you'll see it again. We've been talking about this draft as a research group draft and as an individual draft for what will be in Vancouver 2 years. It's been presented at every PANRG session since IETF 100. And I want to say that every revision has been an improvement, and that has been because people have worked on it and contributed to it. Thank you for those people. We can continue to improve this draft in the future, or it might be time for this bird to leave the nest. And the reason I think that is the last two major revisions have been mostly summarizing the draft. The goals for this informational draft are to inform research in this research group, research outside this research group, and engineering outside this research group. And that's the third one is the one I want to call the most attention to. It seems to me that we need to publish in order to inform work outside the research group, especially engineering work. And it seems to me that I see proposals at every IETF cycle that need this document, including during this last IETF cycle, including this meeting week. I've had 3 conversations where I pointed people who were presenting at this IETF to this draft because there were things in their proposals that were covered in here as impediments to deployment. If you look at the diff from 03, you'll see a lot of changes in section 2, but those are mostly formatting changes. I was mostly adding anchors to allow cross-refs from other parts of the document. So you see a lot of diffs there, but not very much changed text. There's a new section called section 3. This is summarizing the discussion we had at IETF 105. And so that summarized summary is on the next slide. If you have comments on that, let's not wordsmith this as a group in the last session on Friday now afternoon. But please send feedback on the list or get a pull request. And I was really happy about the editor's affiliation change, but maybe nobody else cares. But I cared. So I asked the wrong question in IETF 105, but it turns out that the question that I asked didn't change the answer very much, I don't think. What I should have asked was, do we understand this lesson well enough for people who think about this lesson to assess risk? If the answer is yes, we're talking about engineering. If we're talking about no, it's still research. I think that's the question we actually talked about at IETF 105. So the good news is that the research group ignored Spencer's question and talked. That's always the right thing to do. Of the lessons that are summarized in the draft, there are two of them that I don't think, based on the discussion we had at IETF 105, we understand these lessons well enough for people to assess risk. One of them is endpoints trusting intermediate devices. One is intermediate devices trusting endpoints. And for these two lessons, Spencer thinks we need to revisit the internet threat model and note that the IAB has an active discussion on this on the Model T mailing list. And if you click on that in the slides, you get the mailing list sign-up thing. Yari Arko, who is one of the document authors I think the current combined draft, but not, still an individual draft. It hasn't been adopted by the IAB. Yari says that work is really, they're not finished. They're beginning. So given that the IAB is talking about, asking the community to talk about the larger question, I'm not quite sure what we can say as PANRG. So I'll stop there and let both Teresa and Brian explain to me what I should have said.
Teresa Enghardt, no, I think you asked the right question at IETF 105, but this question is kind of related and more specific. So if you define risk as just like the trust sort of, but we had a lot of things about like deployment, is it going to get deployed and so on. And I think asking the broader question is absolutely fine. About the threat model, yes, this is really interesting and we should follow it. I'm not sure like what we can contribute to it. Maybe we can sort of give our angle, our questions about like what does trust mean in our context, and maybe that can help inform those discussions.
Thank you.
Hi, Brian Trammell speaking as an individual, as the editor of the questions doc. I'll point out that your two questions there are question number 2 and question number 3 in the questions doc, but expanded. So the questions doc was basically looking at, this endpoint trusting the intermediate device. How can you get trustworthy path properties to you? And intermediate devices trusting endpoints. These are sort of the superclass questions there. I think I mainly wanted to come up and encourage people in this room who have ideas in this space to go and participate on the Model T list in the IAB, because there was just a message this morning on that list where basically the sense of the room, they had a meeting at 7:30 in the morning on Tuesday, and still managed to get a lot of work done. The sense of the room there was that a lot of this stuff needs to be moved into the IETF sooner rather than later. I don't know if that means that there's going to be drafts that turn into a BOF or what. But since a lot of this is going to update the internet threat model, which is the security considerations, like guidelines for writing security considerations, is the RFC that they need to update or obsolete in order to do that. The wider questions about this endpoint intermediate device trust and intermediate device endpoint trust should be addressed as part of that effort. Having spent 5 years of effort on that question, I am it's Friday and I'm not going to go down a rabbit hole of cynicism. But I mean, there's work to do there. And explicitly the reason that I wanted to frame the questions in the questions draft much more on a much tighter scope with respect to like these properties was to see if there was a way to frame that question in order to make progress on it. And maybe I should take the questions draft to the Model T people. I'm not sure. I'll think about it.
Yeah.
but like this is kind of the this is the spin bit in the room, right? That this is the question that we've been working on pretty hard for a while. People who have ideas in this space should take it to Model T. Thank you.
Yeah, and like I said, I think what we've been trying to do in here in all of our work has been to inform research in and outside the research group, and inform engineering, which is obviously outside the research group. Hi, Colin.
Hi, my name is Colin Perkins. I think if there are things individuals participating here wish to provide as input to the Model T list as individuals, I think that would be a very useful exercise. I think this we should distinguish from revisiting the internet threat model that the standards community uses to frame their standards, and doing research which thinks about some of the threats related to this. And I think there's nothing stopping us doing research about path-aware networking and how it affects endpoints and so on, provided this group is not trying to directly drive what the IETF is doing.
Sure.
So don't stop thinking about these issues, but separate the research questions from the standards process questions.
Right. So this is the retrospective on engineering draft that I'm talking about here. So if I understood what you're saying there, is that we can do research in that space, but not necessarily as part of the retrospective draft. Do you see what I'm saying? We're talking about moving forward, and that won't happen in the what not to do draft, I think.
Right. I mean, this group has produced a draft that says we believe these things are problematic.
Yeah.
And that will be published. And sure.
Yeah.
I don't think this group should be trying to influence what the standards process is doing and how the IETF community defines its threat model. If people from this group wish to participate as individuals in that, I mean, it's an open process. Anyone can participate.
Sure.
That's not an input from the IRTF to that process. That doesn't mean this group can't separately look at issues related to it, provided it isn't directly trying to change what the IETF considers its process.
Sure. Thank you for helping me with that.
Wes Herdeker, ISI. I think in the IETF we get too hung up on this work is not complete until it's published, and we can't publish it until X, and then X is blocking Y. And the reality is that for things like, the work going on here and work going on in Model T, A, hopefully there's a lot of overlap and people will contribute, but B, both groups will end up feeding information to each other, and sure, absolutely, you've got to continue working, because hopefully you'll influence the Model T group regardless of whether it's published with a number at the end of it or a ID with a number at the end of it. Continue just driving the work forward, and both groups will feed each other.
Right. Thank you. So my proposed next steps were basically to do a largely editorial revision to fix up the phrasing around the question I should have asked at 105, and do a research group last call on 05, resolve issues raised during last call, and request publication as an IRTF stream informational draft, and then begin informing proposals inside and outside the research group. And so, like I say, my last slide was going to be, it may be time for this bird to leave the nest, and please discuss. And I'll go ahead and leave the proposed next steps up if anybody runs for the microphone.
We have 2 minutes, so yeah, we can have a couple of comments.
I'm in favor of research group last call, and I'm willing to review. Theresa Enghart.
Thank you.
So
are you still Teresa, or are you the girl with the hair?
So quick question from the chair. My perception watching this document evolve over time is that the velocity is going down, right? Is like in terms of like changes to it and like things that we're adding to it, it's like there was sort of this explosion of effort, and now it's sort of, is there anything that could be gained by keeping it open? It looks to me like it's slowing down. Is that your perception as well? Or
Well, it makes a difference what's moving in as well as how fast.
Okay.
What was moving was the contributions. And that's what you're remembering.
Yeah.
Where it's like, the first few times I did this, it's like, well, we added material on, we added material on diffserv, or whatever it was. So the sections, the contributions which are in section 5 now, I think, because the section numbers keep changing, but the contributions that are there, we kept adding those. What has been changing, and I don't know that the word count of the changes have been quite trailing off, but what has been changing has been that we've been adding more and more text that was summarizing the contributions and the lessons learned from those contributions. We haven't added any contributions in a couple of IETF cycles, and we haven't added any lessons in a couple of IETF cycles. So I think we may be to the point where it's more important for people to read this outside the research group than it is for us to continue to improve it.
Okay, thanks. So I guess, yeah, we'll wait for the next revision and then we'll start RGLC.
That works for you all. Thank you.
Thank you very much.
It really turns out to be critical to attend the Pechacucha talks, because we keep using words from last night like, we're spin bitting this, or we're going down the rabbit hole, or, things like that were discussed there. That's turned out to be a really key part of the IETF week.
Yeah, those videos will be available soon, right, Aaron?
Not an official IETF activity.
But it's almost official IETF terminology now, right?
It's a working group forming not official activity.
Okay. Gori Bob, you are next. Who's... clicker.
So there is a Gori first, and this is Bob, and the Pechacucha's got some disadvantages. Doing these slides just before the Pechacucha didn't make them the best set of slides, but most of the stuff in is actually okay, and I think we're ready to talk about this, aren't we? The title is MTU is hard. Getting packets bigger. Bigger packets don't simply get there. But right. We start with an application. It sends some data, and we have a notion of how big a piece of data we can send. In TCP, that's MSS. Maybe it's max datagram. Lots of different words are used here. And then the transport has some notion of kind of how much you can send, and the network layer's got a notion of how big a packet is. And in fact, it's got more than one notion, because it's got a size of actually the subnet it's using, and the size it thinks it's using, and the interface size. There's lots of things going on here. It's not just as easy as sending a big packet down a pipe and it comes out on the network. Are you going to interrupt at some point, Bob?
Maybe.
Oh, okay. But the solution to this is great. We did it years and years ago. We take big packets and we make them smaller in the network, and they come out big at the end because we reassemble them. Read RFC 791 and you figure out how it all works. Then we discovered in 1987, so this is kind of relatively recently, fragmentation was a harmful thing to do, because when you break a packet up into lots of pieces, they don't all arrive in the same order, and what happens if one of them doesn't get there, and what happens if you get bits of ones that you didn't actually send, and yeah, it's not possible to kind of do this. So what we want to do is get the network to tell you how big a packet to send. Here's the network signal.
And if I can just add, and it's only gotten worse from then. So with all the new kinds of boxes in the middle that decide they know better than the end. So it's, yeah, fragmentation has gotten worse than it was at the beginning.
Yeah, and there's some helpful boxes that don't read the RFCs and tries to put packets together or try and do other helpful things for you. So fragments have problems. Right, save the day. Let's not really do fragments. Let's just tell the network, if you can't send a big packet, send a signal back for your path, and we'll tell you how big a packet to send. It's all very great and good. It was done in 1990, in 1191. The transport simply gets a signal from the path saying, here's how big a packet you should send. And that was a good idea. Yeah, except that wasn't such a good idea to do ICMP messages, was it, Bob?
Well, again, I think it was a fine idea, but there's a lot of boxes decided not to send them or filter them out, or in theory, there were even some boxes that didn't actually have a route back to the source, which surprised me.
Well, this is because these people building paths actually built two paths. One went this way, one went that way. So if something went wrong in the forward direction, the ICMP message can come back because there's no way getting back on that path. So we're building paths that is not as easy as you think. And it was sadly tricky to implement in TCP as well because of the MSS thing. And what TCP decided to do was simply decide at the beginning, hey, how big a packet can you send? And the boxes in the middle on the path read the MSS value, and they change it to reduce it to the correct size it should have been sent to, because obviously they know better than the endpoint. So what the endpoint learns is, I can only use this size across the network path. It's called MSS clamping, widely deployed, great technology. It's what makes the network work with TCP, so that's really good. It's not an IETF way of doing it, but it's the way it works currently. And sadly, this is where we got to. But there's more. Some people think fragmentation is still harmful after we've done all this, and we have to think about it because IPv6 helpfully has fragmentation.
But of course, we made it so the routers in the middle didn't do it, only the endpoints, which we thought was better, and we thought it would help discourage the use of fragmentation, but apparently not.
Right. Okay. So we have this document, and it's with the RFC editor. So now it's going to be BCP sometime this year. Oh, wait. Hey, wait. I don't want to go that. How can I get that fast? Where did I get to? Back here. Yeah. So resetting. If ICMP was harmful, then maybe the transport shouldn't really rely upon ICMP. So back in a while ago, we invented if we take, is that where we got to? Yeah. Right. That's fine. Missing one slide that I didn't show. The slide is we invented something else, but I'll come back to that. If ICMP was harmful, it was harmful in various ways. One way was we do see some ICMP messages that contain just the wrong information. These horrible people building routers actually managed to get some code wrong. I think some of them are little endian versus big endian, and the number you get back is kind of just swapped. So you get kind of like a bit of wrong advice. That's just awkward. That's not really the big problem with the signal. The big problem with the signal is when these handy network layer people designed PathMTU discovery, they thought this was a great signal, and they didn't know how to check whether it was a signal from somebody who actually saw your packets on your path, or whether it was someone helpful somewhere else in the internet who was just telling you to use a certain packet size. At the time, that wasn't really a big issue. Now we call it like a DOS attack. Okay.
Yeah, any network signal, useful network signal, can be abused, I guess.
Yeah. And so you have to have a way to verify it. You can find out it's got an encapsulated packet. Maybe we should have always checked that and checked it actually matched the flow we were trying to send at the transport. So we can do it. That's great. And if we have it, then maybe the ICMP message are a little bit useful. Maybe they're hints, useful advice from the network about what to do. Maybe the transport layer can use this to check to see whether the network path actually supports it. And if it does, hey, that's a great idea. We get to the right value very quickly. And if the transport layer finds it doesn't work, then it doesn't say the ICMP message must have been right and I'm wrong. It simply says that size doesn't work. I will choose a different size. So we can go quite a long way with this. This is quite a good way of doing things. And it's the way that PLP MTUD now saves the day. PLP packetization layer path MTU discovery puts the problem at the transport layer. and it takes signals in from these probes to decide what to do. It's been implemented in SCTP. It's in the quick spec. There's a spec with the IESG on how to do it with stun. There's other ways of doing this. This is now a general method, and I think the working transport TSVWG at the bottom is going to be published next year. Prediction. I don't know when things really get published. But this is a mechanism that's kind of robust and works well. It takes path signals and does useful things with them. And you can use ICMP messages optionally to help you find about the path. Maybe you can use other signals. Maybe extension headers.
Is there another slide?
Yeah, we can go on extension headers more. Extension headers, some people proposed in IPv6 don't work across all paths, but it's not actually a problem. You can get path information that's just hints, just useful stuff. So if it works in some place and tells you something useful, then you can use it. So there's an interesting thing. Maybe path signals don't have to be accurate. They just have to be good advice, and then you can probe and check they work. Are we going forward? There we go. So next thing, how much of this is real in future? Well, the first thing is, how big a packet can we actually send? Don't really know. Operators have been deploying routers and switches that support big packets in many parts of the internet. Many people at home can't send big packets. Well, what's the real state of play? Which parts of the internet do what? I mean, we don't actually know. If you know, just come and tell me, and I don't have to do this talk again. If not, I'm going to try and start measuring this. The other thing is, how about extension headers? We know they don't reliably work. We've got lots of evidence that some people drop them. What about those people who forward them? Where can they be forwarded? How much can we use them for something useful? This is why Bob's here, because Bob and I have a nice draft that says let's use a hop-by-hop extension header to figure out the MTU of the path. If we get it, we have a hint. We have a great piece of information. If we don't, well, it doesn't matter. We will carry on doing the PLP MTUD algorithm and find a way ourselves. So this is good. I'm promoting a couple of tools we're using. PathSpider is a measurement tool for testing lots of different hosts, different paths through the network, and gathering some big mapping of what is actually done. That's quite useful in this, and we want that data. We also have another tool called PathTrace, which takes a particular path and tries to figure out where on the path something happens that changes the packets or the forwarding behavior. If we use these tools together, we can map the entire of the internet and figure out whether everybody's house will support all these mechanisms. We can't do that. We'll have to do a smaller measurement campaign, alas, but we'll try and make it a big one and try and give some real data. I like the idea of doing measurements now. We did some measurements already. Do you want to say which one was your probe? My probe was the one in Aberdeen.
Yeah, and I live in Palo Alto, so I think you can guess which are mine. And we're trying to figure out why my measured results for hop-by-hop options was 0%. So we have two guesses, either the ISP or my actual home router. But we'll see what we find out. But this is real data.
And this is why you need two types of tool, one to figure out what's going along the path and one to just do the mapping exercise. We're going to work with some people and figure out why these answers are here. So do not take this as a measurement of what the internet supports. Take it as an indication that we can do good work in this space. And it's not hopeless. There are places where you can even use hop-by-hop options to find out useful stuff. Could be cool. This is a summary, isn't it? We want to deploy more probes. You notice there was only like 3 columns here. Talk to us if you like these measurements. Talk to us if you want to measure paths. We're talking just about sending bigger packets. Once we have the probes, we can test other things that happen on paths, and we are really passionate about trying to measure these other things. But you do have to have some prerequisites to join our measurement activity. Either give us good data, which is always welcome, or offer to host a probe but have a big MTU support, so we can probe for the MTU, and have IPv6 support, preferably IPv6 extension header support, so we can actually measure extension headers. And summary, doing MTU is hard. Actually, it's not hard just to find, it's taken a long, long time to get here. The IETF has made lots of bad decisions on the pathway. We believe we're now making the right decisions. Unfortunately, the other people probably thought that too, but I think we are. It's not a network problem, unless you're talking about tunnels, in which case everything's completely different. Sorry. It is a transport problem, unless you're talking about tunnels. And the only thing you can trust is your own probes sent by your own endpoint to test your path. But you can get lots of helpful hints from other devices on the path to help you know how to build those probes. And I think that's where we're at.
Right. And I have 2 of these probes in my house at the moment, and I'm looking for another home in the San Francisco Bay Area. So if you have access to a data center that's, more in the middle of the network, please let me know. We could meet and I could give it to you.
Hi, Colin Perkins. Can you, whether here or just to the mailing list, sort of summarize what you need to run one of these probes, and do you have an easy script to test if someone's network is suitable for running it?
Possibly. Let me think. I think the question. I think it's Friday.
Yeah.
We have a number of these probes, and we are considering other ways of doing this experiment as well. So if you're interested in the experiment, just contact us, I think.
Please
and we'll send a reminder.
Please actually do send that out to the list as well. I think you got a fair amount of people in this room and on that list that might be willing to help. And
yeah, we'll send the request to the list. That's what we'll do. And then that will let you follow up in the way you need to.
Yep.
Sure. So, is it like a Linux box or something like that you need, or is it something custom hardware? Or
did we have a picture, or did we? I think we took the picture out of the slide deck to save one slide. It's a small box that runs Linux. Looks like a home router to run it as we currently have it. We could run it as a VM because we know that some people want to run it as a VM, but there are different ways of measuring. We might use different probes for different things.
Okay, thank you.
Tell us if you're interested. We'll send an email to the list asking people.
Thank you. And go to, I think you stay in, right?
Okay, I stand in the middle this time.
Okay.
It's not so much fun without Bob. It's really nice to have like IPv6 network layer people and transport people in the same box, you see. So this is a different talk. It's maybe not quite as concrete, and it talks about a bit of history about asymmetric path characteristics. So I'm going to take it for a little bit of view from TCP. If you're less interested in TCP, you're interested in multimedia or even Quick or something, then there's a little bit of stuff later, but let's learn about TCP. And TCP connections have a use for 2 parts of the path. They use data in the forward part of the path and other control signaling, and they receive ACKs in the return part of the path. And we use these ACKs to control the speed at which the TCP sender works. So they help with the congestion control. And the basic rule is a TCP receiver sends an ACK for every 2 MSS of data. Read 2 packets, that's more normal. Except not quite always. We send an ACK every segment to increase the C wind at the beginning in some more or less randomly hard to express way, but actually works quite well for just a little while. And we also use them whenever there's a loss to make sure the loss information gets through. Then you have an asymmetric path. One path goes in one way, another path comes in another way. They might actually just be on the same cable, and it's the 2 directions are different. And the amount of ACKs you get back can constrain the amount of data you send. Simple reason for this could be you have much lower bit rate on one direction and higher bit rate on the other direction. The high bit rate link can't be used because it fills up the return link with ACKs. And TCP doesn't really know how to deal with this. There's bits and pieces, but most people have deployed boxes on the path, which is why it's interesting here, that help you. The first is an easy box. You simply compress the data because ACKs are quite compressible usually. You could press them away using header compression. ROC does this. Works well, used widely in cellular environments, helps a lot with this asymmetry problem. You could deploy ACK thinning. RC3449 again, a little bit of history, talks about ACK thinning as a way of kind of filtering the ACKs that aren't necessary. ACKs are cumulative. You can get rid of all the ones you don't need. If you're smart in the network and you understand which flows are which ACKs are more valuable than which, whether the ACK is cumulative or reordered or whatever, you could just filter them. You could imagine some boxes are smarter than other boxes. And some boxes are really smart because they use these methods called compacting, companding, and expanding, which means that they regenerate the ACK clocking in some way. So actually, when they remove the ACKs, they kind of put them back again, which all seem great stuff. Maybe it doesn't fit today's security model, but it was seen as good stuff at the time and is still widely done for TCP. There's a more strange thing at the bottom, which is really cool if you're doing measurements, which is the ACKs for scheduling scheme, which says that ACKs are tiny bits of data, so why not put them at the front of the queue? So if you have ACKs and data, then just shuffle the ACKs to the front. If you think that's amusing, then have a look at it. If you don't understand the issues with that, then think it's a problem. But they're widely deployed, these methods, and they sit on the path. They deal primarily with differences in capacity. Capacity is a big issue, always was, isn't actually the biggest issue. The biggest issue is when you have a radio link. If you have a radio link of any type, which kind of, is just many types of links we actually find in the internet, then it's not actually the volume of data that's the problem. The problem is that when you transmit a packet, you incur a certain amount of resource in actually sending it over the radio link. Supposing you use different technologies or different configurations on the return link to the uplink, every ACK you send consumes radio resource. It may be the total cost of sending an ACK is the same as sending a data packet. So you spend 2 data packets, you send 1 ACK packet, 2 data packets, 1 ACK packet. This is kind of disproportionately using 1/3 of your radio resource for sending ACKs. Not good. Actually, much worse than this, because the radio link in the return direction is often contention-based or a demand assignment, managed in completely different technology, completely different radio characteristics. It costs more to send ACKs than it does to send data often. Really, TCP doesn't know about all this. So people have deployed ACK thinning and other methods to solve this. And they reduce the ACK rate rather than the ACK volume in this case. And it really has a big effect on your system design. That doesn't mean your network runs faster or slower because of this. What it affects is the bottom line cost for the person providing the network. So if you're the radio operator, the ISP, you have a cost, and this reduces your cost, which probably reduces subscription costs for the service. So there is a round effect. It does affect the user. Okay, all the background done. This is what TCP does. Here's delayed ACK after slow start. If you want a pretty slide of it, you start sending lots of ACKs, then you send less ACKs, and it works. This is a real plot. Next slide. What about Quick? Quick. We should think about Quick because Quick has taken a different security model. If you were smart, you would realize that all this great stuff that's been keeping the internet afloat for years no longer works. Well, okay, so we have the same path, but the path is different because we use Quick and we encrypt the ACKs and the data packets. What's Quick trying to do? It tries to send, according to the current spec, an ACK every 2 packets. It mimics TCP. So actually, it's just inherited the same problem as TCP. It's got an ACK delay interval. It's slightly better because if you've got a loss, then it only acts for a little bit of time, and then it realizes you don't have to send ACKs continuously, and it doesn't need to use delayed ACKs after slow start because that was a TCP thing. But the basic thing is you can't use any of these performance-enhancing devices on your path. Even though they might have been really simple radio layer stuff, they still don't work with this. So what does it look like when you use Quick? Real measurements from various Quick stacks show they implement the spec. Yeah, they're implementing the IETF spec. That's great. So they do ACK every 2 packets. How much volume of data they send? Oh, it's actually worse. In the measurements we've done, this is a 10 megabyte download. Yes, it is ACKs in bytes. For those people who saw this presentation, I forgot to do the vertical column. For the total aggregate of traffic, Quick sent twice as many bytes as TCP. So it's protocol itself needs less asymmetry. In other words, the ACK traffic more impacts quick than it did for TCP. Paths that are asymmetric will have bigger problems. Why? Packets are smaller. The blue part is the easy bit. TCP packets tend to be a little bit bigger than quick packets. Previous talk applies. Let's do this stuff and get the packets bigger because the overhead is significant. The red part on the Linux stack is the actual ACKs. That's just simple TCP segments. And we go to quick and we find the combination of IP and transport is about the same. Okay, you can wiggle and you can tell me that the crypto stuff in quick could have been done in TCP, but actually it's not very important in terms of total performance. The quick ACKs are not as compact as the TCP ACKs. Yeah, that's what the spec says. How do we fix this? Maybe we just change the ACKing policy. We have thinning in TCP, so we can do this in quickly and said one ACK every 10 segments. Yeah, could do it. People have talked about it. Maybe people will talk about it more in the IETF. Maybe we can fix this. Maybe we just change the protocol to understand the path. This is with 2, and this is now over a satellite link where we have asymmetric capacity, also asymmetric radio considerations, and ACKing every 2 packets looks like this. If we change to ACK every 10 packets, lo and behold, the code we have seen actually being people using just works. Well, there's maybe a few things to consider, but really, we can change the behavior to it with this. So, conclusion. If we knew the path capacity resources had asymmetry, we could know what to do. Is it a great signal from the network? No. I've tried to argue, actually, this is a transport problem. So asymmetry in the network, I think, is not a great thing to signal because you don't really, most of the time, know what path you're using. If you're on the local radio link yourself, if you're connected to a Wi-Fi or directly to a cellular device, maybe you can say something about your local link. That would certainly help in the same way as it helped for path MTU discovery. But really, I think this particular one is something that needs to be done at the transport. And I think we probably need to do some form of ACK congestion control, rate adaptive ACKing to deal with the fact that the paths are not symmetric. So this one isn't a greater talk here because really, after looking at it all, we find out that there's not a lot the path can help with. We have to live with the fact the path is asymmetric. So we need tools to know how asymmetric it is so we can debug it. Because one of the things I need to know as somebody using this network is whether these paths are symmetric. What's happening to my traffic so I can understand what's going on, which is complicated. But the fix is actually, I think, at the transport layer without signals from the path in this case. Unless somebody tells me otherwise, which is why I am presenting it.
Thank you, Gori. We have 7 minutes for questions, comments.
Spencer Dawkins, thank you for bringing this here, Gori. This is terrific for us to think about. The one thing that I was going to say, just to make this more of a research problem, probably, is I didn't hear you talking a lot about the situation where like the physical path is changing.
That's okay. I think you're right, Spence, because I think that's what can cause this as well as the radio link.
Well, I'm talking about the remembering problems and adapting.
Yes.
And then the plane flew over the mountain.
Yeah.
And so remembering might make things better, or you might be remembering old information and have to recover from that. Yes. So I think that, like I say, I think this is terrific, and I think this is terrifically important.
Yeah.
This is directly relevant to a project, a proposal that I saw in an IETF working group within the past 3 days. And surprise, I pointed them at what not to do, but this is a much This is a much better description of specifically what they're looking at. Thank you for bringing it.
Yeah, and just to follow up on what Spencer said, if we have boxes on the path, we might have various things chained together on the path. We saw that earlier. Then it'd be nice to have good tools to know what was happening here, so we can debug this stuff at a higher level. you can't just believe things happen magically at a higher level. You need to have tools in the network to understand what's going on to make this stuff evolve at the higher level. Question, please.
Thank you. It's Tim Costello from BT. It's a very good presentation and nice results in there. I work also on 5G standards, and I'm coming from there. The issue on traffic steering, so ATSS we call it over there, and which uses the multipath protocols in here. So your path can change mid anything really, over wireless, satellite, or residential broadband. Have you got consideration of that in here that I could then go and look at?
No, but I mean, don't trust the path at all. I mean, like you could trust it for a while, and it really can change. And yeah, I buy that. I hope it doesn't change so fast that it disrupts what goes on at a higher level. And that might be interesting because some people would motivate it should change fast enough that it doesn't change the service that's given across the network. So here we have a little bit of tussle between whether the path's trying to help you by doing the migration or whether you are trying to cope with the fact that the path's moving. So I'd be interested to talk and figure out what the problems are.
Thank you.
Andrew McGregor, Fastly. I think the common thing there is with memory and in transports and so forth is the layers below transport need to supply signal at a rate that is tolerable for transport to learn what is going on, and transport needs to be mindful of its own learning rate, and so effectively look like a Kalman filter and know how wrong it could be. Right?
I mean, the interesting thing there might be, Andrew, aren't you? Yeah, I know, but I'm just making sure people know. The interesting thing, Andrew, is can we just have a huh signal? We used to have those in the olden days. It doesn't necessarily have to say, hey, my path asymmetry has changed and it's now like this. Just a huh, something's changed underneath that I can believe. I know it came on path, therefore I can trust it. And the transport then says, oh, maybe time to probe now rather than kind of waiting a little bit longer. Might help a lot. We haven't tried that here.
Yeah.
I mean, maybe we can find a better name, but
path characteristics probe solicitation. Yeah. It seems like a cool idea.
Eric Kinnear, just to note about the something has changed signal. We don't do anything like that on a path right now, but at least within a client device, when something changes, we take a signal and we say, hey, we should probably look at some of the things that we're currently estimating about the transport that we have, and not necessarily toss everything away, but be much more aggressive about updating to the fact that we may have a significantly different situation than we did a second ago.
That's a first hop signal, an interface signal, I guess, is it? Yeah. Okay. Spencer?
Oh, sorry.
Oh, Nicholas, whichever.
Spencer Dawkins. I kind of going back to the what not to do draft, we're deep in the territory of things that have been impediments to deployment in the past. And the assertion during my presentation was that we understood the issues well enough to do engineering. So for people to be thinking about that, as we have the discussion, I think would be terrifically helpful to maybe them, to me, and to the research group.
Yeah, and we wouldn't want to repeat those bad stories. Being too explicit might actually be a way of repeating that. So let's figure out how to not repeat the bad stuff and do something good.
Yeah, move on to new and exciting mistakes.
Nicholas?
Nicolas Kuhn from CNES. I have two small comments. First, are we sure it's because of asymmetry or large RTT? To what extent the RTT has an impact on that? If we can do measurements together if you want. I mean, I think it's relevant to experiment the same characteristics with a high RTT but no asymmetry. We have satellite links to do so.
Okay,
we should do that. And I wanted
so there are probably path issues that arrive due to high RTT, which are either separable or are sometimes mixed in with them. And this will be an interesting thing to unpick about paths.
Yeah. Okay.
just to very quickly interject, Eric Kinnear. I was looking at some data the other day that suggested that with a constant RTT, if you change the asymmetry of the path, you see these effects. So that it's not actually the RTT, it really is the asymmetry.
Okay, I would like to cut the line after people who are in the line. Yeah, yeah.
Okay, thank you for this useful information. And also on, you mentioned, my second point was related to your first comment on what you do at the client level. At the moment, there are things that are done in specific client implementations in Quick and that are not clearly exchanged between the client and the server, at least it's not in the standard today.
Yep.
And we have a draft in Quick to actually exchange information between clients and servers, that the estimations you have on the path, on one way, so that you can actually use and measure asymmetry and exchange information publicly between clients, and not publicly because it's still within the Quick secure layers. But still, that's something that may be worth considering to measure asymmetry and then decide if you use this information to adapt your acknowledgement rate.
Yeah, okay. Yeah. And to be useful, it has to work across all paths. So we need some sort of standard in that space. I buy that. That's an interesting.
Chijinsu Hughes, it's very interesting talk. Could you extend to that study to BBR, the impact of aggregation on BBR?
Would I like to comment on BBR? Yes. BBR v1 wasn't as good. BBR v2 is by definition better. Right. I don't know. Somewhere buried in those slides, I mentioned things about rate-based methods and other interactions. So I think there's more to this to come as we unravel this story.
Because you increase the throughput from 4 to 5 here, but
yes.
What is the impact for the BBR, right?
Feedback, yeah. Okay. Feedback is something that we have to get right, and yeah. Okay, so I mean that's fun, and I'm so pleased that people started asking questions here. And I think that there are follow-on things we could work on. So happy to talk about that using the research group mailing list.
Yeah, please do. Okay, thank you very much. Thank you for who presented and who commented and was in the room. Please raise your hand if you have not signed those blue piece of paper. Oh, okay, I'll come to you. And thank you, and see you in Vancouver.
And thank you very much for staying to the very, 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 very end of IETF 106.